Question 1. Risk assessment procedures indicate that a critical DB210, one LUW database hosting sensitive financial data, requires an upgrade to DB210. 5. The primary concern is to ensure data integrity and application functionality post-upgrade with minimal disruption to ongoing financial transactions. Which of the following approaches best mitigates the risks associated with this upgrade? Option A. Implement an in-place upgrade on the production system, immediately followed by a quick verification of database connectivity, and plan to address any application issues as they arise after the system is live. Option B. Conduct a full upgrade simulation on a staging environment that precisely mirrors the production setup, including application servers and network configurations, followed by rigorous data validation and application testing before proceeding with the production upgrade. Option C. Perform the upgrade directly on the production server during a scheduled maintenance window, relying on the DB2 upgrade utility to handle all data transformations and assuming application compatibility. Option D. Upgrade the DB210, one database to DB210, 5 on a separate, less critical server, and then manually migrate a subset of the data to verify basic functionality without testing the full application suite. Correct answer is C. Perform the upgrade directly on the production server during a scheduled maintenance window, relying on the DB2 upgrade utility to handle all data transformations and assuming application compatibility. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades, ensuring data integrity and application compatibility while minimizing downtime. The professional challenge lies in balancing the need for a thorough upgrade process with the business's demand for continuous availability. A misstep can lead to data corruption, application failures, significant financial losses, and reputational damage. The DBA must possess a deep understanding of DB2 upgrade paths, potential compatibility issues, and robust rollback strategies. Correct approach analysis. The correct approach involves a phased upgrade strategy with comprehensive testing at each stage. This aligns with best practices for critical system upgrades, emphasizing risk mitigation. Specifically, performing a dry run of the upgrade process on a non-production environment that mirrors the production setup is crucial. This allows for the identification and resolution of any unforeseen issues, such as data conversion errors, performance regressions, or application incompatibilities, before impacting the live system. Thorough validation of data integrity and application functionality post-upgrade in the test environment provides confidence for the production rollout. This methodical approach minimizes the risk of production outages and data loss, which are paramount concerns in any regulated environment where data accuracy and availability are often mandated. Incorrect approach is analysis. An approach that skips comprehensive testing in a staging environment and proceeds directly to a production upgrade without a validated rollback plan is professionally unacceptable. This demonstrates a disregard for potential risks and a failure to adhere to due diligence. Such an action could lead to severe data corruption or application downtime, violating implicit or explicit service level agreements and potentially contravening data protection regulations if sensitive information is compromised. Another incorrect approach would be to rely solely on automated upgrade scripts without manual verification of critical data structures or application configurations. While automation is beneficial, it cannot account for all nuanced dependencies or custom configurations that might be specific to the application's interaction with DB2. This oversight can result in subtle data inconsistencies or functional errors that are difficult to detect and rectify post-upgrade, leading to potential compliance issues and user dissatisfaction. Finally, an approach that prioritizes speed over thoroughness, such as performing the upgrade during peak business hours without adequate contingency planning or a clear rollback strategy, is also professionally unsound. This demonstrates a lack of risk management and a failure to consider the business impact of potential failures. It can lead to extended downtime, significant financial losses, and a breach of trust with stakeholders. Professional reasoning. Professionals should adopt a risk-based approach to database upgrades. This involves identifying potential risks, assessing their impact and likelihood, and implementing mitigation strategies. A structured methodology, including thorough planning, extensive testing in representative environments, clear communication with stakeholders, and a well-defined rollback plan, is essential. The decision-making process should prioritize data integrity, application stability, and minimal business disruption, always considering the potential regulatory and business consequences of any chosen path. Question 2. Governance review demonstrates a critical need for enhanced data integrity verification during the upcoming IBM DB2 5 LUW upgrade from DB2 1. The review specifically mandates that all data modification activities during the upgrade process must be comprehensively logged and auditable to ensure compliance with internal data governance policies and to provide a clear audit trail for regulatory purposes. Which of the following approaches best satisfies these governance requirements for data integrity verification during the upgrade? Option A. Rely solely on manual review of transaction logs after the upgrade to identify any data inconsistencies. Option B. Temporarily disable DB2 auditing features during the upgrade to maximize performance and minimize upgrade time. Option C. Assume that the DB2 upgrade process inherently maintains data integrity and forego specific auditing measures for modifications. Option D. Enable DB2 built-in auditing features to capture all data modification events throughout the upgrade process. Correct answer is D. Enable DB2 built-in auditing features to capture all data modification events throughout the upgrade process. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades, ensuring data integrity and compliance with established governance policies. The professional challenge lies in balancing the technical requirements of the upgrade with the need to adhere to strict data handling and auditing protocols. The DBA must not only execute the technical steps, but also ensure that the process itself is auditable and aligns with the organization's data governance framework, which is critical for regulatory compliance and internal control. Correct approach analysis. The correct approach involves leveraging DB2 built-in auditing capabilities to capture all data modification activities during the upgrade process. This aligns with best practices for data governance and regulatory compliance. By enabling auditing, the DBA creates an immutable record of all changes, which is essential for post-upgrade verification, troubleshooting, and demonstrating compliance with data integrity requirements. This proactive approach ensures that the upgrade process is transparent and accountable, satisfying the governance review's mandate for oversight and control. This is crucial in regulated environments where data lineage and change control are paramount. Incorrect approaches analysis. One incorrect approach is to rely solely on manual log reviews. This is professionally unacceptable because manual reviews are prone to human error, are time-consuming, and do not provide a systematic or easily verifiable audit trail. It fails to meet the governance requirement for robust and automated data integrity checks. Another incorrect approach is to disable auditing to improve performance during the upgrade. This is a significant regulatory and ethical failure. Disabling auditing undermines data integrity controls, making it impossible to track changes, identify unauthorized modifications, or reconstruct events if issues arise. This directly contravenes governance policies that mandate comprehensive logging and auditing for all critical database operations. A further incorrect approach is to assume that the upgrade process itself inherently preserves data integrity without explicit verification. This is professionally negligent. Governance frameworks require explicit verification and auditing of critical processes, especially those involving data migration or transformation. Relying on assumptions rather than verifiable evidence is a failure of due diligence and can lead to undetected data corruption or compliance breaches. Professional reasoning. Professionals should approach such situations by first understanding the specific governance and regulatory requirements applicable to their jurisdiction and industry. This involves consulting internal policies, compliance mandates, and relevant legal frameworks. The decision-making process should prioritize solutions that provide verifiable evidence of compliance and data integrity. In the context of a DB2 upgrade, this means actively seeking out and utilizing the database's native auditing and logging features. When faced with performance concerns, the professional approach is to explore optimization techniques or phased auditing rather than compromising essential controls. A robust decision-making framework involves 1. Identifying all applicable requirements. 2. Evaluating technical solutions against these requirements. 3. Prioritizing solutions that offer auditable proof of compliance. And 4. Documenting all decisions and their justifications. Question 3. Implementation of a DB210, 1 to DB210. 5 upgrade for a critical financial application requires careful consideration of downtime and data integrity. The DBA team is evaluating different strategies to minimize risk and ensure a successful transition. Which approach best balances these requirements while adhering to standard upgrade best practices? Option A. Upgrade the DB210. 1 binaries to DB210. 5 on the production server, but skip the database migration and application compatibility testing, assuming backward compatibility. Option B. Rely exclusively on automated upgrade scripts provided by IBM, executing them directly on the production database without manual verification or understanding of the underlying steps. Option C. Perform a direct-in-place upgrade of the DB210. 1 binaries to DB210. 5 on the production server, followed by a database migration without prior testing in a separate environment. Option D. Conduct a thorough upgrade process in a staging environment that mirrors production, including database migration and application testing, before scheduling the production upgrade during a planned maintenance window. The correct answer is C. Perform a direct-in-place upgrade of the DB210, 1 binaries to DB210. 5 on the production server, followed by a database migration without prior testing in a separate environment. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades, ensuring data integrity and application availability while minimizing downtime. The professional challenge lies in balancing the need for a robust upgrade process with the business's demand for continuous operation. Incorrectly handling the upgrade can lead to data corruption, extended outages, and significant financial losses, impacting customer trust and regulatory compliance. Careful judgment is required to select the most appropriate upgrade strategy based on the specific application's tolerance for downtime and the complexity of the data environment. Correct approach analysis. The correct approach involves a phased upgrade strategy that includes thorough testing in a non-production environment that mirrors the production setup as closely as possible. This allows for the identification and resolution of potential issues before they impact live operations. The use of IBM's recommended upgrade paths and tools, such as DB2 Up10, 5, and DB2 C2090, is crucial for ensuring compatibility and adherence to best practices. This approach minimizes risk by validating the upgrade process and its impact on application functionality and data integrity. It aligns with general IT best practices for change management and risk mitigation, which are implicitly supported by regulatory frameworks that mandate data accuracy and system reliability. Incorrect approach is analysis. One incorrect approach involves performing a direct-in-place upgrade on the production system without prior testing. This is a high-risk strategy that bypasses essential validation steps. It fails to adhere to standard IT change management principles, which are often a component of broader regulatory compliance frameworks requiring system stability and data integrity. The potential for unforeseen compatibility issues or data corruption is extremely high, leading to significant downtime and potential data loss, which could violate data protection regulations. Another incorrect approach is to upgrade only the database binaries without migrating the database itself or testing application compatibility. This overlooks the critical step of ensuring that the new DB2 version's features and internal structures are correctly applied to the existing database. It also fails to account for potential application code changes or configuration adjustments that might be necessary to leverage or even function with the upgraded database. This approach risks database corruption or application failure due to incompatibilities, violating the principle of ensuring system functionality and data integrity. A third incorrect approach is to rely solely on automated upgrade scripts without manual verification or understanding of the underlying processes. While automation is valuable, it should not replace human oversight and validation, especially for critical database upgrades. Over-reliance on automation without understanding can lead to subtle errors being missed, which could have significant consequences. This approach lacks the due diligence required to ensure a successful and compliant upgrade, potentially leading to issues that could have been prevented with proper manual review. Professional reasoning. Professionals should adopt a risk-based approach to database upgrades. This involves 1. Understanding the application's criticality and downtime tolerance. 2. thoroughly reviewing IBM's upgrade documentation and recommendations for the specific versions involved. 3. Creating a detailed upgrade plan that includes rollback procedures. 4. Performing comprehensive testing in a staging environment that closely replicates production. 5. Executing the upgrade during a planned maintenance window. 6. Post-upgrade validation and monitoring. This systematic process ensures that potential issues are identified and addressed proactively, minimizing risk and ensuring a smooth transition, while adhering to best practices for system maintenance and data management. Question 4. Operational review demonstrates that the DB2 one database environment supporting critical financial reporting applications is due for an upgrade to DB2. 5. The upgrade window is limited due to business cycle constraints, and there is significant pressure to minimize downtime. The DBA team has proposed several strategies for the upgrade. Which of the following upgrade strategies best balances the need for a timely upgrade with the imperative to ensure data integrity and application stability for all users? Option A. Perform the DB2 5 upgrade on a separate, isolated server, migrate a sample of data, and then proceed with the full production upgrade, assuming the sample data migration was successful. Option B. Initiate the DB2 5 upgrade on the production system, and, upon encountering any application errors, immediately initiate a rollback to DB2 1 without further investigation. Option C. Execute the DB2 5 upgrade directly on the production environment during the scheduled maintenance window, followed by immediate application testing by the development team. Option D. Implement a phased rollout of the DB2 5 upgrade, beginning with a small group of internal users and a subset of the financial reporting applications, followed by a gradual expansion to all users and applications based on successful pilot outcomes. The correct answer is C. Execute the DB2 5 upgrade directly on the production environment during the scheduled maintenance window, followed by immediate application testing by the development team. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades, ensuring data integrity and application compatibility without causing extended downtime. The professional challenge lies in balancing the need for a smooth transition with the critical requirement of maintaining business operations. The DBA must make informed decisions about the upgrade strategy, considering potential risks and the impact on end users and business processes. The pressure to complete the upgrade quickly can lead to shortcuts that compromise data quality or system stability. Correct approach analysis. The correct approach involves a phased rollout strategy, starting with a pilot group of users or a non-production environment. This allows for thorough testing of the upgraded database with the actual application workload. It provides an opportunity to identify and resolve any compatibility issues, performance regressions, or data corruption problems in a controlled manner before impacting the entire user base. This methodology aligns with best practices for risk management in IT projects, minimizing the potential for widespread disruption and data loss. It also allows for iterative refinement of the upgrade process based on feedback from the pilot phase, ensuring a more robust and successful final deployment. This approach is implicitly supported by general IT governance principles that emphasize testing and validation before full production deployment to ensure system reliability and data integrity. Incorrect approaches analysis. Implementing the upgrade directly to all production users without prior testing in a representative environment is a significant regulatory and ethical failure. It violates the principle of due diligence in IT operations, which mandates thorough testing to prevent system failures and data loss. Such an approach exposes the organization to substantial business risk, potentially leading to financial losses, reputational damage, and non-compliance with data protection regulations if data is compromised or unavailable. Performing a rollback immediately after encountering minor issues without a clear understanding of the root cause is also professionally unsound. Rollbacks are a necessary contingency. An immediate and unanalyzed rollback can mask underlying problems, leading to repeated failures. It demonstrates a lack of systematic problem solving and can indicate insufficient preparation or diagnostic capabilities, potentially violating service-level agreements, SLAs, and impacting business continuity. Focusing solely on the upgrade timeline without adequate consideration for application compatibility testing is another critical failure. Applications are intrinsically linked to the database. Ignoring compatibility can lead to application errors, data inconsistencies, and a complete breakdown of business functionality, directly impacting operational efficiency and potentially violating regulatory requirements related to data accuracy and availability. Professional reasoning. Professionals should adopt a risk-based approach to database upgrades. This involves 1. Comprehensive planning, understanding the scope of the upgrade, potential impacts and dependencies. 2. Thorough testing, implementing a multi-stage testing strategy, including unit testing, integration testing, and user acceptance testing, UAT, in environments that closely mirror production. 3. Phased rollout, deploying the upgrade to a subset of users or systems before a full production rollout. 4. Robust monitoring, continuously monitoring system performance and application behavior post-upgrade. 5. Contingency planning, having a well-defined rollback strategy and disaster recovery plan in place. This systematic process ensures that potential issues are identified and addressed proactively, minimizing disruption and safeguarding data integrity, thereby upholding professional responsibility and adherence to IT best practices. Question 5. The assessment process reveals that a critical application relies on complex stored procedures and dynamic SQL statements that interact with sensitive financial data. The organization is planning an upgrade from DB2.10.1 to DB2.10.5 for LUW. The primary concern is to ensure that all application functionalities remain operational and that no data corruption occurs after the upgrade. Which of the following approaches best addresses these concerns? Option A. Conduct extensive application-level testing, including unit, integration, and regression testing, on a staging environment that closely mirrors production before proceeding with the production upgrade. Option B. Rely solely on the DB2 Upgrade Advisor tool to identify and resolve any potential compatibility issues, then proceed with the production upgrade. Option C. Implement the DB2.10.5 upgrade directly into the production environment to minimize downtime, and then address any application issues as they arise. Option D. Perform only database-level checks, such as verifying table structures and data counts, after the upgrade to confirm basic data integrity. The correct answer is A. Conduct extensive application-level testing, including unit, integration, and regression testing, on a staging environment that closely mirrors production, before proceeding with the production upgrade. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades, ensuring data integrity and application compatibility without disrupting critical business operations. Professional challenge lies in balancing the need for a smooth, efficient upgrade with the absolute requirement to maintain data accuracy and application functionality. The DBA must anticipate potential issues that could arise from changes in DB2 internal data handling or SQL parsing between versions, especially when dealing with complex application logic. Careful judgment is required to select the most appropriate testing and validation strategy. Correct approach analysis. The correct approach involves a multi-phase testing strategy that simulates real-world conditions as closely as possible. This includes unit testing of individual SQL statements, integration testing to verify application modules interact correctly with the upgraded database, and user acceptance testing, UAT, to confirm end-user functionality. Regression testing is paramount to ensure that previously working features remain functional. This comprehensive approach directly addresses the core requirement of the C2090-311 exam, successfully upgrading from DB2.10.1 to 10.5 while minimizing risk. It aligns with best practices for database administration, emphasizing thorough validation before production deployment. The focus on application-level testing, beyond just database-level checks, is crucial for ensuring a seamless transition for end users and preventing unexpected application errors post-upgrade. Incorrect approaches analysis. Performing only database-level checks, such as verifying table structures and data counts, is insufficient. This approach fails to account for potential changes in SQL statement execution plans or subtle differences in data type handling that might only manifest during application runtime. Represents a significant regulatory failure by not adequately ensuring data integrity and application functionality, which are implicit requirements for maintaining business operations. Relying solely on the DB2 Upgrade Advisor tool without further testing is also inadequate. While the advisor can identify potential compatibility issues, it cannot predict all application-specific behaviors or performance regressions. This approach risks overlooking critical application-level problems, leading to potential data corruption or service disruption, which constitutes a failure to meet professional due diligence standards. Implementing the upgrade directly to production without any pre-production testing is a severe professional and ethical failure. This bypasses all validation steps, exposing the production environment to a high risk of failure, data loss, and extended downtime. It directly violates the principle of responsible system management and could have significant financial and reputational consequences for the organization. Professional reasoning. Professionals should adopt a risk-based, phased approach to database upgrades. This involves 1. Thoroughly understanding the changes between DB2 versions, particularly those impacting data types, SQL processing, and internal mechanisms. 2. Developing a comprehensive testing plan that includes unit, integration, regression, and user acceptance testing. 3. Creating a detailed rollback plan in case of unforeseen issues. 4. Communicating potential risks and the testing strategy to stakeholders. 5. Executing the upgrade in a non-production environment that mirrors production as closely as possible. 6. Monitoring the production environment closely post-upgrade. Question 6. Strategic planning requires a proactive approach to database upgrades. A DB210. One DBA for LUW is tasked with upgrading to DB210. 5. The DBA has reviewed the IBM documentation and understands the general upgrade steps. However, the production environment is complex, with several custom applications heavily reliant on specific database features and performance characteristics. The DBA is under pressure to complete the upgrade quickly to take advantage of new features. What is the most critical step to ensure a successful and low-risk upgrade? Option A. Conduct thorough testing of the upgrade process and application compatibility in a staging environment that mirrors production, and develop and validate a comprehensive rollback plan. Option B. Proceed with the upgrade directly in the production environment, relying solely on the vendor's upgrade documentation to expedite the process. Option C. Perform the upgrade during the busiest business hours to minimize the perception of downtime, without extensive pre-upgrade testing. Option D. Skip the creation of a rollback plan to save time, assuming the upgrade will be successful based on vendor documentation. The correct answer is A. Conduct thorough testing of the upgrade process and application compatibility in a staging environment that mirrors production, and develop and validate a comprehensive rollback plan. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades, ensuring data integrity and application compatibility without causing extended downtime. The professional challenge lies in balancing the need for a smooth transition with the critical requirement of maintaining business operations. The DBA must consider the potential impact of the upgrade on existing applications, the effectiveness of rollback strategies, and the adherence to internal change management policies, all while working within the constraints of a production environment. Correct approach analysis. The correct approach prioritizes a comprehensive pre-upgrade assessment and a well-defined, tested rollback plan. This aligns with best practices for database administration and IT service management, which emphasize risk mitigation and business continuity. Specifically, thorough testing of the upgrade process in a non-production environment, development, staging, is crucial to identify potential issues before they impact production. Developing and validating a rollback strategy ensures that the organization can quickly revert to the previous stable state if the upgrade fails, minimizing data loss and service disruption. This proactive approach directly supports the principle of maintaining service availability and data integrity, which are fundamental to responsible IT operations. Incorrect approaches analysis. One incorrect approach involves proceeding with the upgrade based solely on vendor documentation without performing independent testing. This is professionally unacceptable because it ignores the unique configuration and application dependencies of the specific production environment. Relying solely on vendor documentation can lead to unforeseen compatibility issues, data corruption, or performance degradation, violating the implicit ethical obligation to protect the integrity of the data and the availability of the service. Another incorrect approach is to skip the rollback plan to save time. This is a critical failure in professional practice. A rollback plan is not an optional step. It is a fundamental component of risk management for any significant system change. Failing to have a tested rollback plan means that if the upgrade encounters an unrecoverable issue, the organization may face prolonged downtime, significant data loss, and severe business impact. This demonstrates a lack of due diligence and a disregard for business continuity, which are core professional responsibilities. A third incorrect approach is to perform the upgrade during peak business hours to minimize perceived downtime, without adequate testing or a rollback plan. While minimizing downtime is a goal, attempting it without proper preparation is reckless. This approach prioritizes speed over safety and can lead to catastrophic failure during a period of high business activity, amplifying the negative consequences. It demonstrates a misunderstanding of the upgrade process and a failure to prioritize the stability and integrity of the production environment. Professional reasoning. Professionals should adopt a structured decision-making process that begins with a thorough understanding of the system, its dependencies, and the potential risks associated with any change. This involves 1. Comprehensive assessment of the current environment and the proposed change. 2. Detailed planning, including defining success criteria, identifying potential issues, and developing mitigation strategies. 3. Rigorous testing in representative environments. 4. Development and validation of a robust rollback plan. 5. Controlled execution of the change, often during scheduled maintenance windows. 6. Post-implementation verification and monitoring. This systematic approach ensures that changes are implemented safely, effectively, and with minimal disruption to business operations, upholding professional standards of care and responsibility. Question 7. Investigation of a DB2 1-10. 5 LUW upgrade scenario where the primary business objective is to leverage new performance features, but the maintenance window is extremely tight. The DBA has identified several potential compatibility issues with custom applications that have not been actively maintained. What is the most prudent approach to ensure a successful upgrade while minimizing business risk? Option A. Delay the upgrade until all custom applications have been fully refactored and certified by their respective development teams, even if this significantly exceeds the planned timeline. Option B. Perform a minimal set of critical path tests in a development environment and then execute the upgrade in production, planning to address any application issues post-upgrade. Option C. Proceed directly with the upgrade in the production environment during the maintenance window, relying on the DBA's experience to address any immediate issues as they arise. Option D. Conduct a full regression test suite on a staging environment that precisely mirrors production, followed by a phased rollout to production with intensive monitoring and a predefined rollback plan. The correct answer is D. Conduct a full regression test suite on a staging environment that precisely mirrors production, followed by a phased rollout to production with intensive monitoring and a predefined rollback plan. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades, ensuring data integrity and application availability while adhering to strict operational timelines. The DBA is tasked with a critical upgrade from DB2 1-10. 5 for low, a process that inherently carries risks of data corruption, performance degradation, or unexpected application behavior. The professional challenge lies in balancing the need for thorough testing and validation against the pressure to complete the upgrade within a defined maintenance window. Failure to adequately test can lead to significant business disruption and financial loss, while overly cautious or prolonged testing can delay critical business initiatives. The DBA must demonstrate technical expertise, risk management skills, and effective communication with stakeholders. Correct approach analysis. The correct approach emphasizes a phased, risk-mitigated strategy that aligns with best practices for database upgrades. This involves comprehensive pre-upgrade planning, including thorough documentation of the current environment, defining rollback procedures, and establishing clear success criteria. The core of this approach is the execution of a pilot upgrade in a non-production environment that closely mirrors the production system. This pilot allows for the identification and resolution of potential issues, performance tuning, and validation of application compatibility without impacting live users. Post-pilot, a staged rollout to production, potentially involving a subset of users or a read-only period, further minimizes risk. This methodical, iterative process ensures that the upgrade is stable, reliable, and meets all functional and performance requirements before full deployment. This aligns with the principle of due diligence in IT operations, aiming to prevent foreseeable harm to the business and its customers. Incorrect approach is analysis, an approach that skips comprehensive testing in a non-production environment and proceeds directly to a full production upgrade, is a significant regulatory and ethical failure. It demonstrates a disregard for risk management and a failure to exercise due diligence. This could lead to data loss or corruption, violating data integrity principles, and potentially contravening data protection regulations if sensitive information is compromised. It also exposes the organization to severe business disruption and reputational damage. Another incorrect approach involves performing extensive testing, but failing to document the process or establish clear rollback procedures. This is professionally unsound as it leaves the DBA and the organization vulnerable if issues arise during or after the upgrade. Without proper documentation and rollback plans, troubleshooting becomes chaotic, and recovery is significantly hampered, increasing the likelihood of prolonged downtime and data loss. This reflects poor planning and a lack of preparedness, which can have severe operational and financial consequences. Finally, an approach that prioritizes speed over thoroughness, cutting corners on validation steps to meet an arbitrary deadline, is also professionally unacceptable. This demonstrates a lack of commitment to quality and a failure to uphold professional standards. It increases the probability of introducing subtle bugs or performance issues that may not be immediately apparent but can cause significant problems later. This can lead to a breach of service level agreements (SLAs) and erode customer trust. Professional reasoning. Professionals should adopt a structured, risk-based approach to database upgrades. This involves 1. Comprehensive planning. Understand the scope, identify dependencies, and define clear objectives and success metrics. 2. Risk assessment. Identify potential risks and develop mitigation strategies, including robust rollback plans. 3. Non-production testing. Execute the upgrade in a representative test environment, simulating production workloads and application interactions. 4. Validation and performance tuning. Thoroughly test functionality, performance, and security in the test environment. 5. Staged production rollout. Implement the upgrade in production incrementally, monitoring closely at each stage. 6. Post-upgrade monitoring. Continuously monitor the system for performance and stability. 7. Communication. Maintain clear and consistent communication with all stakeholders throughout the process. This systematic process ensures that the upgrade is performed efficiently, effectively, and with minimal disruption, upholding professional responsibility and safeguarding business operations. Question 8. What factors determine the most appropriate strategy for upgrading a DB210? 1. LUW database to DB210. 5. Considering application dependencies and acceptable downtime windows. Option A. The availability of the latest DB2 fix pack for version 10. 5. And the perceived complexity of the database schema. Option B. The personal experience of the DBA with previous DB2 upgrade projects and the current workload of the production server. Option C. The thoroughness of pre-upgrade testing in a staging environment, the existence of a well-defined rollback plan, and the application's tolerance for downtime. Option D. The number of concurrent users accessing the database at the time of the upgrade and the total size of the database in gigabytes. The correct answer is C. The thoroughness of pre-upgrade testing in a staging environment, the existence of a well-defined rollback plan, and the application's tolerance for downtime. Explanation. This scenario presents a common challenge during database upgrades, ensuring data integrity and application compatibility without causing extended downtime. The professional challenge lies in balancing the need for a smooth transition with the critical requirement of maintaining business operations. IBM DB210. 5 DBA for LUW upgrade from DB210. 1. Necessitates a thorough understanding of the upgrade process, potential pitfalls, and the tools available to mitigate risks. Careful judgment is required to select the most appropriate upgrade strategy based on the specific application workload, tolerance for downtime, and available resources. The correct approach emphasizes a phased, well-tested upgrade strategy that prioritizes data consistency and minimizes application impact. This involves thorough pre-upgrade planning, including comprehensive testing of the new DB2 version with the application in a non-production environment. The use of tools like the DB2 Upgrade tool with appropriate options for smooth transition, followed by rigorous post-upgrade validation, ensures that the upgrade meets functional and performance requirements. This aligns with best professional practices by adhering to a systematic and risk-averse methodology, which is implicitly supported by general IT governance principles that advocate for controlled change management and data protection. While specific regulations for DB2 upgrades are not typically mandated in a prescriptive manner, the underlying principles of data integrity, availability, and security are paramount and are often reflected in broader IT compliance frameworks. An incorrect approach that bypasses thorough testing in a staging environment before proceeding to production is professionally unacceptable. This failure to validate the upgrade in a representative setting significantly increases the risk of encountering unforeseen issues post-upgrade, potentially leading to application failures, data corruption, or extended downtime. Such an approach demonstrates a disregard for established change management best practices and could be seen as a violation of implicit service level agreements or internal IT policies designed to ensure system stability and data integrity. Another incorrect approach that relies solely on the default upgrade settings without considering application-specific requirements or potential performance impacts is also professionally flawed. This can lead to suboptimal performance or unexpected behavior after the upgrade, impacting user experience and business operations. It fails to acknowledge that a one-size-fits-all approach is rarely effective in complex database environments. A third incorrect approach that neglects to establish a robust rollback plan before initiating the upgrade is a critical oversight. Without a clear and tested procedure to revert to the previous DB2 version, if the upgrade fails or causes severe issues, the organization is left vulnerable to prolonged outages and potential data loss. This demonstrates a lack of preparedness and risk management, which are fundamental to professional IT operations. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the requirements. Clearly define the goals of the upgrade, including performance targets, downtime windows, and application compatibility. 2. Assess the risks. Identify potential issues associated with the upgrade, such as data corruption, performance degradation, or application incompatibility. 3. Plan the strategy. Select an upgrade method, e.g., in-place migration, and develop a detailed plan including pre-upgrade tasks, execution steps, and post-upgrade validation. 4. Test thoroughly. Conduct comprehensive testing in a staging environment that mirrors the production setup. 5. Prepare for rollback. Develop and test a rollback plan to revert to the previous version if necessary. 6. Execute with caution. Implement the upgrade during a planned maintenance window with close monitoring. 7. Validate and monitor. Perform post-upgrade verification and ongoing monitoring to ensure stability and performance. Question 9. When evaluating the most effective and risk-averse strategy for upgrading a production IBM DB2 1 database to version 10.5 on Linux/Unix/Windows LUW, which approach best balances the need for minimal downtime with the imperative of data integrity and application stability? Option A. Initiate the upgrade process on the production server immediately, relying on IBM support to troubleshoot any encountered problems in real time. Option B. Conduct a pilot upgrade on a staging environment that mirrors the production setup, including application testing, and have a thoroughly tested rollback plan in place before proceeding with the production upgrade. Option C. Skip pre-upgrade health checks and compatibility assessments to expedite the upgrade, proceeding directly to the production environment with a basic rollback script. Option D. Perform a direct in-place upgrade on the production system during a low activity period, assuming the new version will be backward compatible and any issues can be resolved post-upgrade. The correct answer is B. Conduct a pilot upgrade on a staging environment that mirrors the production setup, including application testing, and have a thoroughly tested rollback plan in place before proceeding with the production upgrade. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades, ensuring data integrity and application compatibility without causing extended downtime. The professional challenge lies in balancing the need for a smooth transition with the critical requirement of maintaining business operations. The DBA must make informed decisions about the upgrade strategy, considering potential risks and the impact on end users and business processes. The complexity is amplified by the need to adhere to specific upgrade paths and best practices outlined by IBM for DB2 5 from 10. 1. which are implicitly governed by the need for reliable and secure database operations, a core tenet of IT professional responsibility. Correct approach analysis. The correct approach involves a phased upgrade strategy that includes thorough pre-upgrade checks, a pilot upgrade on a non-production environment, and a rollback plan. This aligns with best professional practices for database administration, emphasizing risk mitigation and validation. Pre-upgrade checks ensure that the existing environment meets the prerequisites for the new version, preventing unexpected failures. A pilot upgrade allows for testing the upgrade process, identifying potential issues with data, applications, and performance in a controlled setting. The existence of a well-defined rollback plan is crucial for minimizing business impact in case of unforeseen problems during the production upgrade. This methodical approach ensures data integrity, application functionality, and adherence to operational stability requirements, which are fundamental to responsible database management. Incorrect approaches analysis. Performing a direct-in-place upgrade on the production system without prior testing in a non-production environment is a significant regulatory and ethical failure. This approach disregards the principle of due diligence and risk management. It exposes the production system to a high probability of failure, potentially leading to data corruption, extended downtime, and severe business disruption. Such an action would violate the implicit professional obligation to maintain system stability and data integrity. Skipping the pre-upgrade health checks and compatibility assessments before initiating the upgrade process is another critical failure. This oversight can lead to the upgrade failing due to unmet prerequisites or encountering compatibility issues that could have been identified and resolved beforehand. This demonstrates a lack of thoroughness and adherence to established upgrade methodologies, increasing the risk of data loss or system instability. Proceeding with the upgrade without a documented and tested rollback strategy is professionally irresponsible. In the event of a critical failure during the production upgrade, the absence of a rollback plan means there is no clear or tested path to revert to the previous stable state. This can result in prolonged outages and significant data loss, directly contravening the professional duty to ensure business continuity and data protection. Professional reasoning. Professionals should approach database upgrades by first understanding the specific upgrade path and prerequisites outlined by the vendor, IBM in this case. This involves consulting official documentation and release notes. The decision-making process should prioritize risk assessment and mitigation. This includes 1. Thoroughly understanding the current environment and its compatibility with the target version. 2. Planning and executing a pilot upgrade in a representative non-production environment. 3. Developing a comprehensive rollback plan that has been tested. 4. Communicating the upgrade plan and potential risks to stakeholders. 5. Executing the production upgrade during a planned maintenance window with adequate monitoring. 6. Having a clear post-upgrade validation process. This structured approach ensures that the upgrade is performed efficiently, reliably, and with minimal disruption to business operations, upholding professional standards of care and responsibility. Question 10. Cost-benefit analysis shows that upgrading from DB2 1 to 5 might incur immediate costs for testing and potential downtime, while skipping this intermediate step and aiming for a significantly later version of DB2 could offer perceived long-term savings by reducing the number of upgrade projects. However, the current DB2 1 environment is nearing its end-of-support lifecycle. What is the most professionally responsible course of action for the DBA? Option A. Delay the upgrade to DB2 5 indefinitely, citing current budget limitations and reassessing the need for an upgrade in the future. Option B. Skip the DB2 5 upgrade and attempt a direct upgrade to a much newer DB2 version to achieve greater long-term cost efficiencies. Option C. Proceed with the upgrade to DB2 5 as per IBM's recommended upgrade path, ensuring continued support and stability. Option D. Investigate third-party support options for DB2 1 to extend its operational life while deferring the upgrade to 5. The correct answer is C. Proceed with the upgrade to DB2 5 as per IBM's recommended upgrade path, ensuring continued support and stability. Explanation. This scenario presents a common challenge during database upgrades, balancing the desire for immediate cost savings with the long-term risks associated with unsupported software versions. The professional challenge lies in making a decision that is technically sound, financially responsible, and compliant with IBM's support lifecycle policies, which are implicitly part of the operational framework for a DBA. The core of the decision-making process involves understanding the implications of deviating from recommended upgrade paths and the potential consequences. The correct approach represents best professional practice because it prioritizes system stability, security, and maintainability. By adhering to IBM's recommended upgrade path from DB2 1 to 10.5, the DBA ensures access to ongoing support, bug fixes, security patches, and performance enhancements. This proactive stance minimizes the risk of encountering critical issues that could lead to downtime, data corruption, or security breaches, all of which have significant financial and reputational costs that far outweigh any perceived short-term savings. This aligns with the professional responsibility to maintain a robust and secure database environment, an incorrect approach that suggests skipping the 10.5 upgrade and proceeding directly to a much later version, while seemingly efficient, carries significant regulatory and ethical failures. IBM's support lifecycle dictates that versions prior to 10.5 may no longer receive critical security updates or bug fixes, leaving the database vulnerable to known exploits. This failure to maintain a supported environment can be seen as a breach of professional duty to protect company data and systems. Furthermore, attempting a direct leap to a significantly newer version without intermediate steps can introduce unforeseen compatibility issues and increase the likelihood of a failed upgrade, leading to extended downtime and potential data loss. This demonstrates a lack of due diligence and a disregard for established best practices in database management. Another incorrect approach might involve delaying the upgrade to 10.5 indefinitely, citing budget constraints without a clear plan for future remediation. This is professionally unacceptable as it knowingly operates in a state of potential risk. While budget is a factor, a responsible DBA would escalate the risks associated with an unsupported version and propose a phased approach or seek alternative funding. The ethical failure here is the passive acceptance of risk without actively mitigating it or informing stakeholders of the potential consequences. The professional decision-making process for similar situations should involve a thorough risk assessment, a clear understanding of vendor support policies, and transparent communication with stakeholders. The DBA must evaluate the technical feasibility, security implications, and long-term operational costs of each potential upgrade path. This includes considering the impact on applications, the availability of skilled personnel, and the potential for downtime. When faced with cost-saving pressures that conflict with recommended best practices, the professional should clearly articulate the risks and potential consequences of the less-than-ideal path, providing data-driven justifications for the recommended course of action. Question 11. The efficiency study reveals that the current DB2 1 database is experiencing performance degradation, impacting critical reporting functions. As the DBA responsible for an upcoming upgrade to DB2 5, what approach best balances the need for improved performance and operational continuity with the imperative of maintaining regulatory compliance and data integrity? Option A. Conduct a phased upgrade to DB2 5, involving thorough pre-migration testing of data integrity, security configurations, and audit trail functionality in a test environment, followed by a controlled production rollout with a documented rollback plan. Option B. Assume that the default configurations of DB2 5 will automatically satisfy all existing regulatory compliance requirements, and proceed with the upgrade without specific validation of audit trails or security settings against current mandates. Option C. Implement a direct, in-place upgrade to DB2 5, focusing solely on migrating data and applying performance tuning parameters identified in the study, with a plan to address compliance issues post-deployment if they arise. Option D. Prioritize the upgrade to DB2 5 based on the efficiency study's performance recommendations, deferring comprehensive validation of audit logs and security settings until after the system is live to minimize downtime. The correct answer is C. Implement a direct, in-place upgrade to DB2 5, focusing solely on migrating data and applying performance tuning parameters identified in the study, with a plan to address compliance issues post-deployment if they arise. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades: balancing the need for rapid deployment with the imperative of maintaining data integrity and regulatory compliance. The pressure to deliver a functional system quickly can lead to shortcuts that might inadvertently violate data governance policies or specific regulatory requirements related to data handling and auditing. The DBA must navigate this tension, ensuring that the upgrade process adheres to established protocols without unduly delaying critical business operations. The challenge lies in identifying and mitigating risks associated with data migration and configuration changes in a live environment, especially when the efficiency study highlights potential performance bottlenecks that could impact compliance-related reporting. Correct approach analysis. The correct approach emphasizes a phased, controlled upgrade process that includes thorough validation and rollback capabilities. This aligns with best practices for database management and regulatory compliance. Specifically, it addresses the need for data integrity by ensuring that all data is accurately migrated and that the new DB2.10.5 environment maintains the same level of auditability and security as the previous version. Regulatory frameworks, while not explicitly detailed here due to the exam's focus on a specific IBM product context, generally mandate that data remains accessible, accurate, and protected throughout system changes. A phased approach allows for granular testing and verification at each stage, minimizing the risk of widespread data corruption or compliance breaches. The inclusion of a rollback plan is crucial for disaster recovery and ensures that the organization can revert to a stable state if unforeseen issues arise, thereby safeguarding against prolonged downtime and potential regulatory penalties for noncompliance. This methodical approach demonstrates due diligence and a commitment to maintaining operational integrity and regulatory adherence. Incorrect approaches analysis. One incorrect approach involves a direct, in-place upgrade without extensive pre-migration testing or a defined rollback strategy. This is professionally unacceptable because it significantly increases the risk of data loss or corruption. Regulatory compliance often hinges on the ability to demonstrate data accuracy and availability. A failed in-place upgrade could render critical data inaccessible or compromised, leading to severe compliance violations and potential legal repercussions. Furthermore, it bypasses essential validation steps that would confirm the integrity of migrated data and the functionality of the new database version, directly contravening the principle of maintaining data trustworthiness. Another incorrect approach is to prioritize speed by skipping the validation of audit trails and security configurations in the new environment. This is a critical regulatory failure. Many compliance mandates require robust audit logging and stringent security controls to protect sensitive data. Failing to validate these aspects post-upgrade means the organization cannot guarantee that all required audit information is being captured or that the system's security posture remains adequate. This oversight could lead to undetected security breaches or an inability to provide necessary audit evidence to regulators, resulting in significant penalties. A third incorrect approach might be to assume that default DB2.10.5 settings will automatically meet all existing compliance requirements without specific verification. This is a dangerous assumption. While IBM provides robust features, specific regulatory requirements often necessitate custom configurations for auditing, data retention, or access controls. Relying on defaults without explicit validation means the organization might be non-compliant from the moment the upgrade is completed, creating an immediate and ongoing regulatory risk. It demonstrates a lack of proactive risk management and a failure to understand the specific compliance obligations relevant to the organization's data. Professional reasoning. Professionals should adopt a risk-based approach to database upgrades. This involves a thorough assessment of potential impacts on data integrity, security, and regulatory compliance. The decision-making process should prioritize 1. Understanding all applicable regulatory requirements and internal data governance policies. 2. Developing a comprehensive upgrade plan that includes detailed testing phases, clear success criteria, and a robust rollback strategy. 3. Executing the plan methodically, with continuous monitoring and validation at each step. 4. Documenting all actions, decisions, and test results to provide an auditable trail. When faced with pressure to expedite, professionals must clearly articulate the risks associated with shortcuts and advocate for adherence to best practices that safeguard both the data and the organization's compliance standing. Question 12. The risk matrix shows potential performance degradation and extended downtime during the DB210.5 upgrade from DB210. 1. Considering the organization operates within a jurisdiction with strict data privacy regulations, which of the following actions is the most critical to undertake before proceeding with the upgrade to ensure regulatory compliance? Option A. Schedule a series of performance tuning sessions for the new DB210.5 environment after the upgrade is successfully completed. Option B. Prioritize the upgrade of hardware infrastructure to support the new DB2 version, assuming this will indirectly address any potential compliance issues. Option C. Obtain sign-off from the project sponsor on the technical rollback plan, focusing solely on restoring the previous database state in case of failure. Option D. Conduct a comprehensive review of data access controls and audit logging mechanisms to ensure they align with current data privacy regulations and will function as expected post-upgrade. The correct answer is D. Conduct a comprehensive review of data access controls and audit logging mechanisms to ensure they align with current data privacy regulations and will function as expected post-upgrade. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades where the primary focus is on technical execution, potentially overshadowing critical regulatory compliance aspects. The challenge lies in balancing the immediate need for a successful technical migration with the long-term imperative of adhering to data privacy and security regulations. A DBA must not only understand the technical intricacies of the DB2 upgrade, but also how these changes might impact the organization's compliance posture, particularly concerning data handling and access controls. The risk matrix, while highlighting potential technical issues, might not explicitly detail the regulatory implications, requiring the DBA to proactively consider these. Correct approach analysis. The correct approach involves proactively identifying and mitigating regulatory risks associated with the DB2 upgrade. This means understanding how the upgrade process, new features, or configuration changes might affect data classification, access permissions, audit logging, and data retention policies. By consulting with legal and compliance teams, the DBA ensures that the upgrade plan incorporates necessary controls to maintain compliance with relevant data protection regulations. This approach represents best professional practice because it embeds regulatory considerations into the technical project lifecycle, preventing costly remediation or breaches post-upgrade. It demonstrates a commitment to responsible data stewardship and adherence to legal obligations, which is paramount in regulated industries. Incorrect approach is analysis. One incorrect approach is to solely focus on the technical aspects of the upgrade, assuming that existing compliance measures will automatically carry over or are unaffected. This fails to acknowledge that database upgrades can introduce new vulnerabilities or alter data access patterns, potentially leading to noncompliance with data privacy laws. Another incorrect approach is to delay regulatory review until after the upgrade is complete. This is a reactive and risky strategy, as it may uncover significant compliance gaps that require extensive and disruptive rework, potentially impacting business operations and incurring fines. A third incorrect approach is to delegate the entire responsibility for regulatory compliance to another department without active collaboration. While other departments have expertise, the DBA is on the front lines of data management and must be an active participant in ensuring compliance related to the database environment. This lack of direct involvement can lead to misinterpretations or overlooked critical controls. Professional reasoning. Professionals should adopt a risk-based approach to database upgrades, integrating compliance considerations from the outset. This involves 1. Understanding the regulatory landscape applicable to the data being managed. 2. Conducting a thorough impact assessment of the upgrade on data security, privacy, and auditability. 3. Engaging proactively with legal, compliance, and security teams to identify and address potential risks. 4. Documenting all compliance-related decisions and actions taken during the upgrade. 5. Establishing clear communication channels to ensure all stakeholders are aware of regulatory requirements and the steps being taken to meet them. This systematic process ensures that technical objectives are met without compromising legal and ethical obligations. Question 13. The control framework reveals that during the planned upgrade of IBM DB2 1 to 10, 5 for low, the DBA team is considering different strategies for handling sensitive customer data in non-production environments used for testing the upgrade. Which approach best aligns with regulatory compliance and professional data stewardship responsibilities? Option A. Perform the upgrade on a test environment and then retrospectively apply data masking, only if issues are identified during the testing phase. Option B. Rely on the inherent security of the development environment to protect sensitive data, and therefore, no specific data handling measures are required for test data. Option C. Proceed with testing the upgrade directly on a production-like environment without any data sanitization, assuming that the data is only for internal testing purposes. Option D. Implement robust data masking or anonymization techniques on test and staging environments that contain copies of production data to obscure sensitive information before the upgrade is tested. Correct answer is D. Implement robust data masking or anonymization techniques on test and staging environments that contain copies of production data to obscure sensitive information before the upgrade is tested. Explanation. The control framework reveals a critical juncture in the DB2 upgrade process from version 10.1 to 10.5, specifically concerning the management of sensitive data during the migration. This scenario is professionally challenging because it requires balancing the imperative of a successful technical upgrade with the stringent requirements of data privacy and regulatory compliance. The DBA must ensure that the upgrade process itself does not inadvertently expose or compromise sensitive information, which could lead to severe legal penalties, reputational damage, and loss of customer trust. The chosen approach must demonstrably adhere to the principles of data protection and security mandated by relevant regulations. The correct approach represents best professional practice because it proactively addresses data security throughout the upgrade lifecycle. By implementing robust data masking or anonymization techniques on any test or staging environments that mirror production data, the DBA ensures that sensitive elements are obscured without compromising the integrity of the testing process. This aligns with the principle of least privilege and data minimization, fundamental tenets of data protection regulations. It demonstrates a commitment to safeguarding data at every stage, which is a core ethical and professional responsibility for any database administrator. This proactive stance minimizes the risk of data breaches and ensures compliance with data privacy laws. An incorrect approach that involves performing the upgrade directly on a production environment without any data sanitization or masking for testing purposes is a significant regulatory and ethical failure. This exposes sensitive production data to potential risks during the upgrade process, violating data privacy principles and potentially contravening regulations that mandate the protection of personal or confidential information. Another incorrect approach, such as neglecting to validate the effectiveness of masking techniques on test data, also constitutes a failure. This oversight can lead to the inadvertent exposure of sensitive data if the masking is insufficient, thereby undermining the entire security measure and creating a compliance gap. A third incorrect approach, which is to assume that data in a development environment is inherently safe and requires no special handling, is also a critical failure. Development environments, while not production, can still contain sensitive data and are often less secured, making them vulnerable targets. Failing to apply appropriate data protection measures in such environments is a breach of professional duty and regulatory expectation. Professionals should employ a decision-making framework that prioritizes risk assessment and regulatory adherence. This involves thoroughly understanding the data types involved, identifying applicable regulations e.g., GDPR, CCPA, or specific industry mandates, and then designing an upgrade strategy that incorporates security controls at each phase. This includes planning for secure data handling in development, testing, and staging environments, as well as the production environment. Regular audits and validation of security measures are also crucial components of this framework. Question 14. The evaluation methodology shows that during the upgrade from DB2 10.1 to DB2 10.5 for LUW, a critical aspect of the post-upgrade validation process is to ensure adherence to data governance policies and regulatory requirements. Which of the following validation strategies best balances the need for thoroughness with operational efficiency and regulatory compliance? Option A. Relying solely on the DB2 upgrade utility's built-in validation mechanisms without any additional custom testing or manual verification. Option B. Implementing a comprehensive suite of automated data integrity checks across all tables, followed by a targeted manual review of key regulatory fields and security configurations. Option C. Focusing exclusively on performance tuning and application functionality testing immediately after the upgrade, with data integrity and compliance checks conducted as a lower priority. Option D. Deferring all post-upgrade compliance and data integrity checks until the system has been live in production for at least 1 week to observe real-world behavior. The correct answer is B. Implementing a comprehensive suite of automated data integrity checks across all tables, followed by a targeted manual review of key regulatory fields and security configurations. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades, ensuring data integrity and compliance with regulatory requirements without disrupting critical business operations. The challenge lies in balancing the need for thorough testing and validation against the pressure to complete the upgrade quickly. A DBA must navigate potential data corruption, security vulnerabilities, and the risk of non-compliance with data governance policies, all while minimizing downtime. The specific context of upgrading from DB2 1 to 5 for LUW introduces potential compatibility issues and new features that require careful consideration from a regulatory and operational perspective. Correct approach analysis. The correct approach involves a phased, risk-based validation strategy that prioritizes critical data elements and regulatory compliance checks. This aligns with best practices for database upgrades and regulatory frameworks that mandate data accuracy, security, and auditability. By focusing on key data sets and regulatory controls first, the DBA can quickly identify and address high-impact issues. This approach demonstrates due diligence, minimizes the risk of significant data loss or compliance breaches, and allows for a more controlled rollback if necessary. It reflects a proactive stance on risk management and regulatory adherence, ensuring that the upgrade process itself does not introduce new compliance risks. Incorrect approaches analysis. One incorrect approach is to rely solely on automated data validation scripts without manual review of critical regulatory data fields. This fails to account for subtle data corruption or logical inconsistencies that automated scripts might miss, potentially leading to regulatory non-compliance and data integrity issues. Another incorrect approach is to defer all post-upgrade compliance checks until after the system is live in production. This is a high-risk strategy that could result in significant operational disruption and regulatory penalties if compliance issues are discovered late. It demonstrates a lack of foresight and adherence to the principle of compliance by design. A third incorrect approach is to prioritize performance tuning over data integrity and security validation. While performance is important, it should not come at the expense of ensuring the data is accurate, secure, and compliant with all applicable regulations. This approach prioritizes operational efficiency over fundamental data governance and regulatory obligations. Professional reasoning. Professionals should adopt a structured, risk-aware approach to database upgrades. This involves 1. Thoroughly understanding the regulatory landscape applicable to the data being managed. 2. Developing a comprehensive upgrade plan that includes detailed testing and validation phases, with specific checkpoints for data integrity and compliance. 3. Prioritizing validation efforts based on the criticality of data and regulatory impact. 4. Implementing robust rollback procedures. 5. Documenting all steps, decisions, and validation results for auditability. This systematic process ensures that technical objectives are met while upholding regulatory obligations and maintaining data trustworthiness. Question 15. Benchmark analysis indicates that during the C2090-311 IBM DB2 5 DBA for LUW upgrade from DB2 1. A critical consideration is the adherence to U.S. federal data privacy and security regulations. Which of the following approaches best ensures compliance while minimizing upgrade disruption? Option A. Conduct the upgrade with minimal documentation of data handling procedures, prioritizing speed and assuming that standard IT security practices are sufficient for regulatory compliance. Option B. Focus solely on post-upgrade security audits to validate data protection, assuming that the upgrade process itself will not introduce new vulnerabilities. Option C. Implement a phased upgrade strategy with continuous data security and privacy controls, including thorough data classification, access management, and audit logging throughout all stages of the upgrade process. Option D. Expedite the upgrade by deferring detailed data classification and access control reviews until after the DB2.10.5 environment is fully operational, relying on existing security measures. The correct answer is C. Implement a phased upgrade strategy with continuous data security and privacy controls, including thorough data classification, access management, and audit logging throughout all stages of the upgrade process. Explanation: scenario analysis. This scenario presents a common challenge during database upgrades where the primary goal is to ensure minimal downtime and data integrity. The professional challenge lies in balancing the urgency of the upgrade with the critical need for regulatory compliance, specifically concerning data privacy and security as mandated by relevant U.S. federal regulations, e.g., HIPAA for healthcare data, SOX for financial data, or GDPR if applicable to data processed from EU citizens. Though the exam context implies U.S. focus, the DBA must navigate the technical complexities of the upgrade, while ensuring that all data handling practices during the process adhere to these stringent legal requirements. Failure to do so can result in severe penalties, reputational damage, and loss of customer trust. Correct approach analysis. The correct approach involves a phased upgrade strategy that prioritizes data security and privacy throughout each stage. This includes conducting thorough pre-upgrade assessments to identify any sensitive data that might be exposed or mishandled during the upgrade process. Implementing robust access controls and encryption for any temporary data stores or logs used during the upgrade is paramount. Furthermore, ensuring that all personnel involved are adequately trained on data handling protocols and that audit trails are meticulously maintained provides the necessary accountability and transparency required by regulatory frameworks. This approach demonstrates a commitment to compliance by proactively mitigating risks and embedding security and privacy into the upgrade methodology, aligning with the principles of data protection by design and by default. Incorrect approach is analysis. An approach that prioritizes speed over security by skipping detailed data classification and access control reviews during the upgrade process is a significant regulatory failure. This directly violates principles of data minimization and purpose limitation, as sensitive data might be unnecessarily exposed or processed without proper authorization. It also fails to meet the reasonable security requirements often stipulated in data protection laws, leaving the organization vulnerable to breaches. Another incorrect approach would be to rely solely on post-upgrade security checks without implementing preventative measures during the upgrade itself. This reactive stance is insufficient from a regulatory perspective, as many laws require proactive risk assessment and mitigation. It fails to address the potential for data exposure or compromise during the transition, which is a critical window of vulnerability. Finally, an approach that neglects to document the data handling procedures and audit logs during the upgrade process is also a regulatory failure. The lack of comprehensive documentation hinders accountability and makes it impossible to demonstrate compliance if audited. Regulatory bodies often require clear evidence of adherence to data protection policies, which cannot be provided without proper record keeping. Professional reasoning. Professionals should adopt a risk-based approach to database upgrades, integrating regulatory compliance from the outset. This involves 1. Understanding the specific data types and their associated regulatory requirements. 2. Conducting a thorough risk assessment of the upgrade process, identifying potential data exposure points. 3. Developing and implementing security and privacy controls tailored to these risks. 4. Ensuring comprehensive documentation and auditing of all upgrade activities. 5. Training all involved personnel on compliance obligations. This systematic process ensures that technical objectives are met without compromising legal and ethical responsibilities. Question 16. Operational review demonstrates that the upgrade from DB2.10.1 to DB2.10.5 introduces several new data masking and auditing features. Which of the following actions best ensures continued regulatory compliance regarding sensitive customer data during and after this upgrade? Option A. Defer the review of data privacy implications until after the DB2.10.5 5. Upgrade is fully implemented and operational. Option B. Proactively assess the new DB2 5 data privacy features, map them to existing data governance policies and regulatory requirements, and document any necessary configuration changes to enhance or maintain data protection. Option C. Prioritize the technical performance enhancements of DB2 5 and address any data privacy concerns only if they become apparent through operational issues or audit findings. Option D. Rely on the default security and privacy settings of DB2 5, assuming they will automatically satisfy all applicable data protection regulations. The correct answer is B. Proactively assess the new DB2 5 data privacy features, map them to existing data governance policies and regulatory requirements, and document any necessary configuration changes to enhance or maintain data protection. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades, ensuring continued compliance with data privacy regulations while implementing new technical features. The professional challenge lies in balancing the immediate need for upgrade completion with the long-term responsibility of protecting sensitive customer data. A DBA must not only understand the technical aspects of the upgrade, but also the legal and ethical implications of data handling, especially when new functionalities might inadvertently expose or alter data access controls. The pressure to meet project deadlines can tempt shortcuts, making careful judgment and adherence to established protocols paramount. Correct approach analysis. The correct approach involves a proactive and documented assessment of the new features' impact on data privacy controls. This aligns with the principles of privacy by design and privacy by default, which are foundational to many data protection regulations. By thoroughly reviewing the DB2 5 features, specifically those related to data masking, encryption, and auditing, and then mapping these to the organization's existing data governance policies and regulatory obligations, e.g., GDPR, CCPA, or relevant U.S. federal/state laws, depending on the exam's implied jurisdiction. The DBA ensures that the upgrade enhances, or at least maintains, the existing level of data protection. Documenting this assessment and any necessary configuration changes provides an auditable trail, crucial for demonstrating due diligence and compliance to regulatory bodies. This approach prioritizes data security and privacy throughout the upgrade lifecycle, reflecting best professional practice. Incorrect approaches analysis. One incorrect approach is to assume that the default settings of DB2 5 will automatically maintain compliance. This fails to acknowledge that new features might introduce new vulnerabilities or alter existing security postures. Regulatory frameworks often require organizations to actively configure systems to meet specific privacy standards, not passively rely on vendor defaults. This approach risks noncompliance due to a lack of due diligence. Another incorrect approach is to defer the data privacy review until after the upgrade is complete. This is a reactive stance that can lead to significant remediation efforts if issues are discovered post-implementation. It violates the principle of integrating privacy considerations early in the project lifecycle and increases the risk of data breaches or unauthorized access during the interim period. Regulatory bodies emphasize proactive risk management, making this approach professionally unacceptable. A third incorrect approach is to focus solely on the technical performance benefits of the upgrade without considering the data privacy implications. While performance is a key upgrade objective, it cannot supersede the legal and ethical obligations to protect sensitive data. This narrow focus demonstrates a failure to understand the broader responsibilities of a DBA in a regulated environment and could lead to severe legal and reputational consequences. Professional reasoning. Professionals should adopt a risk-based approach to database upgrades, integrating compliance requirements from the outset. This involves 1. Understanding the regulatory landscape applicable to the data being managed. 2. Thoroughly researching new features of the target database version and their potential impact on data security and privacy. 3. Conducting a gap analysis between current compliance controls and those offered or required by the new version. 4. Developing and documenting a remediation plan for any identified gaps. 5. Implementing and testing these changes rigorously before and during the upgrade. 6. Establishing ongoing monitoring and auditing processes to ensure sustained compliance. This systematic process ensures that technical advancements are leveraged responsibly, safeguarding both the organization and its stakeholders. Question 17. Governance review demonstrates that while the upgrade from DB2 1 to 5 is technically feasible and scheduled, there is no documented plan specifically addressing the protection of sensitive customer data during the upgrade process, including backup, migration, and rollback procedures. Which of the following actions best ensures regulatory compliance and professional integrity? Option A. Implement a comprehensive data privacy and security risk assessment and mitigation plan tailored to the DB2 5 upgrade, ensuring all sensitive data handling during the upgrade adheres to relevant data protection regulations. Option B. Assign responsibility for data privacy during the upgrade solely to the compliance department, with the DBA team focusing only on the technical aspects of the database upgrade. Option C. Expedite the upgrade process to minimize the window of potential vulnerability, deferring detailed data privacy planning until after the system is live on the new version. Option D. Proceed with the upgrade as planned, relying on existing general data security policies and assuming standard backup and recovery procedures will satisfy regulatory requirements. The correct answer is A. Implement a comprehensive data privacy and security risk assessment and mitigation plan tailored to the DB2 5 upgrade, ensuring all sensitive data handling during the upgrade adheres to relevant data protection regulations. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades where regulatory compliance, specifically data privacy and security, intersects with technical execution. The professional challenge lies in balancing the imperative to upgrade to a supported version, DB2 5, with the stringent requirements of data protection regulations. The DBA must ensure that the upgrade process itself does not introduce vulnerabilities or lead to non-compliance, especially concerning sensitive data that might be present in the database. This requires a proactive approach to understanding and mitigating risks related to data handling during the upgrade. Correct approach analysis. The correct approach involves a comprehensive risk assessment and mitigation plan specifically addressing data privacy and security throughout the upgrade lifecycle. This aligns with best practices for regulatory compliance, which mandate that organizations implement appropriate technical and organizational measures to protect personal data. For a DB2 upgrade, this means identifying sensitive data, understanding how it will be handled during the upgrade e.g., backups, data migration, schema changes, and ensuring that any temporary storage or processing of this data adheres to the relevant data protection laws. Implementing robust encryption for backups, anonymizing or pseudonymizing data where feasible for testing, and ensuring access controls are maintained or enhanced during the upgrade are critical steps. This proactive, risk-based approach demonstrates due diligence and a commitment to maintaining data integrity and confidentiality, thereby satisfying regulatory obligations. Incorrect approaches analysis. Proceeding with the upgrade without a specific plan for data privacy and security introduces significant regulatory and ethical risks. One incorrect approach is to assume that standard backup and recovery procedures are sufficient for regulatory compliance. This fails to acknowledge that regulatory frameworks often require specific controls for sensitive data, even during routine operations like upgrades. The failure here is a lack of specific risk identification and mitigation for data privacy, potentially leading to unauthorized access or disclosure of sensitive information, a direct violation of data protection laws. Another incorrect approach is to prioritize the upgrade timeline over data security concerns. This demonstrates a disregard for regulatory mandates and ethical responsibilities. The potential for data breaches or non-compliance during a rushed upgrade is high, exposing the organization to severe penalties and reputational damage. This approach prioritizes operational efficiency over fundamental data protection obligations. A third incorrect approach is to delegate data privacy considerations solely to a separate compliance team without direct involvement from the DBA. While collaboration is essential, the DBA is on the front lines of data management and must understand and implement the technical controls required for compliance. This siloed approach can lead to a disconnect between compliance requirements and technical implementation, resulting in gaps in data protection. Professional reasoning. Professionals facing this situation should adopt a risk-based methodology. First, Identify all sensitive data within the database and understand the specific regulatory requirements applicable to that data. Second, conduct a thorough impact assessment of the upgrade process on data security and privacy, considering each phase from planning to post-upgrade validation. Third, develop and document a detailed mitigation plan that includes technical controls, e.g., encryption, access controls, anonymization, and procedural safeguards. Fourth, ensure all team members involved in the upgrade are aware of and trained on the data privacy and security requirements. Finally, establish clear validation and auditing procedures to confirm that compliance has been maintained throughout and after the upgrade. This structured approach ensures that technical objectives are met without compromising regulatory obligations or ethical responsibilities. Question 18. The evaluation methodology shows that during the planning phase for a DB210, 5 LUW upgrade from DB210, 1. The DBA team is considering different approaches to identify and manage potential issues. Which of the following approaches best aligns with professional risk management best practices for ensuring a smooth and secure upgrade? Option A. Focus all testing efforts on post-upgrade validation of core database functionality, assuming that any application-specific issues will be discovered and resolved by the application development teams after the database is live. Option B. Conduct a comprehensive pre-upgrade risk assessment that includes identifying potential application incompatibilities, data migration challenges, and performance impacts, followed by developing detailed mitigation and rollback plans. Option C. Rely exclusively on the IBM release notes for DB210, 5 to understand all potential upgrade issues and proceed with the upgrade immediately after reviewing them. Option D. Prioritize the upgrade timeline by skipping the detailed mapping of application dependencies on specific DB210. 1 features, assuming most applications will function without modification. The correct answer is B. Conduct a comprehensive pre-upgrade risk assessment that includes identifying potential application incompatibilities, data migration challenges, and performance impacts, followed by developing detailed mitigation and rollback plans. Explanation. The evaluation methodology shows a critical juncture in the DB2 upgrade process where a proactive risk assessment is paramount. This scenario is professionally challenging because a successful upgrade from DB210, 1 to 10, 5 on LUW requires meticulous planning to mitigate potential disruptions to critical business operations. The DBA must balance the benefits of the upgrade, new features, performance enhancements, security patches, against the inherent risks of data corruption, application incompatibility, and extended downtime. The pressure to deliver a seamless transition, often under tight deadlines, necessitates a robust risk assessment framework that goes beyond superficial checks. Correct approach represents best professional practice because it directly addresses the core principles of IT risk management, which are implicitly or explicitly mandated by general IT governance frameworks and best practices that would be applicable in a professional DBA context, even without specific U.S. regulatory citations for this exact scenario. A comprehensive risk assessment, involving identification, analysis, and mitigation planning, ensures that potential issues are anticipated and managed before they impact production systems. This aligns with the professional responsibility to maintain system integrity and availability, minimizing business impact. An incorrect approach that focuses solely on post-upgrade testing without pre-upgrade risk identification fails to meet professional standards. This is because it shifts the burden of discovery to the production environment, where the consequences of unforeseen issues are far more severe, potentially leading to data loss or prolonged service outages. This approach demonstrates a lack of foresight and a reactive rather than proactive stance, which is professionally unacceptable. Another incorrect approach that prioritizes speed over thoroughness by skipping detailed application dependency mapping is also professionally deficient. This oversight can lead to critical application failures post-upgrade, as applications may rely on specific DB2 behaviors or features that have changed or been deprecated in version 10. 5. This demonstrates a failure to understand the interconnectedness of the database and its applications, a fundamental aspect of DBA responsibility. A third incorrect approach that relies solely on vendor documentation without internal validation is insufficient. While vendor documentation is a valuable resource, it cannot account for the unique configurations, customizations, and application interactions present in a specific organization's environment. A failure to conduct internal validation and testing based on these specific factors represents a significant professional risk. The professional decision-making process for similar situations should involve a structured risk management lifecycle. This begins with a thorough understanding of the upgrade scope and objectives. Next, potential risks must be identified through various means, including reviewing release notes, analyzing system logs, consulting application owners, and performing dependency mapping. These risks are then analyzed for their likelihood and impact. Mitigation strategies are developed and documented, and contingency plans are put in place. Finally, the effectiveness of these plans is tested and validated before proceeding with the actual upgrade. This systematic approach ensures that all critical aspects are considered, leading to a more controlled and successful outcome. Question 19. Market research demonstrates that organizations often underestimate the complexity of database upgrades, leading to unforeseen issues. Considering the upgrade from DB2.10.1 to DB2.10.5 for LUW environments, which of the following approaches to risk assessment is most likely to ensure a successful and stable transition while adhering to professional best practices for data management and system integrity? Option A. Perform a superficial risk assessment that only considers the most obvious technical risks, such as disk space and memory requirements, without delving into application compatibility or data integrity concerns. Option B. Conduct a comprehensive risk assessment early in the project, involving all relevant stakeholders, to identify potential technical, operational, and security risks, and develop detailed mitigation and contingency plans for each. Option C. Postpone the detailed risk assessment until after the upgrade is completed, focusing only on immediate technical challenges encountered during the deployment phase. Option D. Rely on the vendor's documentation and assume that a newer version of the same product will inherently resolve most potential issues, thus minimizing the need for extensive internal risk assessment. The correct answer is B. Conduct a comprehensive risk assessment early in the project, involving all relevant stakeholders, to identify potential technical, operational, and security risks, and develop detailed mitigation and contingency plans for each. Explanation. Scenario analysis. This scenario presents a common challenge during database upgrades, balancing the need for robust risk assessment with the practical constraints of project timelines and resource availability. The professional challenge lies in ensuring that the risk assessment process is thorough enough to identify potential issues that could impact the upgrade's success, data integrity, and system availability, without becoming an insurmountable bottleneck. The DBA must exercise careful judgment to prioritize risks, allocate resources effectively, and communicate potential impacts to stakeholders, all while adhering to established best practices and potentially regulatory requirements for data handling and system stability. Correct approach analysis. The correct approach involves a structured and iterative risk assessment process that begins early in the upgrade lifecycle and continues throughout. This includes identifying potential risks related to data migration, performance degradation, compatibility issues between DB2.10.1 and 10.5, security vulnerabilities introduced or exposed by the upgrade, and operational impacts. For each identified risk, the DBA should assess its likelihood and potential impact, and then develop mitigation and contingency plans. This approach represents best professional practice because it proactively addresses potential problems, minimizes surprises, and ensures that the upgrade is performed in a controlled and predictable manner. It aligns with general IT governance principles that emphasize risk management as a critical component of successful project delivery and operational stability. While specific regulations for DB2 upgrades are not typically mandated in the same way as financial or healthcare data, the underlying principle of due diligence and responsible system management is universally expected. Incorrect approaches analysis. One incorrect approach is to defer the risk assessment until immediately before the upgrade or to conduct it superficially. This represents a significant regulatory and ethical failure. It demonstrates a lack of due diligence and a disregard for potential negative consequences, such as data corruption, extended downtime, or security breaches. Such an approach could lead to non-compliance with internal IT policies and potentially external service level agreements, SLAs, if system availability is compromised. It is professionally unacceptable because it prioritizes expediency over responsible system management. Another incorrect approach is to focus solely on technical risks and neglect operational or business continuity risks. This is also a failure in professional judgment. While technical issues are critical, the impact of an upgrade extends to how the business operates. Ignoring risks related to user access, application functionality post-upgrade, or the ability to recover from a failed upgrade impacts business operations and can have significant financial and reputational consequences. This oversight can lead to breaches of implicit or explicit commitments to business stakeholders. A third incorrect approach is to assume that because the upgrade is to a newer version of the same product, risks are minimal, and therefore a formal risk assessment is unnecessary. This is a dangerous assumption and a failure to adhere to professional standards. Every upgrade, even within the same product family, introduces changes that can have unforeseen consequences. The absence of a formal risk assessment means potential issues are not identified, documented, or planned for, leaving the organization vulnerable to unexpected failures. This demonstrates a lack of understanding of the complexities of software upgrades and a failure to apply a systematic and cautious approach. Professional reasoning. Professionals should adopt a proactive and systematic risk management framework. This involves 1. Risk identification, brainstorming and documenting all potential risks associated with the DB2 5 upgrade from 10. 1. Covering technical, operational, security, and business aspects. 2. Risk analysis, assessing the likelihood and impact of each identified risk. This can be qualitative, e.g., high, medium, low, or quantitative, depending on the context and available data. 3. Risk evaluation, prioritizing risks based on their analysis to focus efforts on the most critical ones. 4. Risk treatment, developing and implementing strategies to mitigate, transfer, avoid, or accept risks. This includes defining specific actions, owners, and timelines. 5. Risk monitoring and review, continuously tracking identified risks, monitoring for new risks, and reviewing the effectiveness of treatment plans throughout the upgrade project and into the post-upgrade phase. This structured approach ensures that potential problems are anticipated and managed, leading to a more successful and less disruptive upgrade. Question 20. Governance review demonstrates a critical finding regarding potential data integrity vulnerabilities during the DB2 1-10 5 upgrade process, specifically highlighting the need for enhanced audit trail capabilities to meet regulatory compliance standards. Which of the following actions best addresses this finding while ensuring a compliant and secure upgrade? Option A. Conduct a comprehensive risk assessment specifically for the upgrade, identifying potential data integrity and audit trail gaps, and develop detailed mitigation and validation plans before proceeding with the upgrade. Option B. Postpone the upgrade indefinitely until a completely new audit logging solution can be implemented, without a clear timeline for the upgrade itself. Option C. Focus solely on the technical steps of the upgrade, such as schema conversion and performance tuning, and address the governance findings as a post-upgrade task if issues arise. Option D. Proceed with the upgrade immediately, assuming that the inherent stability of DB2 5 will resolve any data integrity concerns and that existing audit trails will suffice. The correct answer is A. Conduct a comprehensive risk assessment specifically for the upgrade, identifying potential data integrity and audit trail gaps, and develop detailed mitigation and validation plans before proceeding with the upgrade. Explanation. Scenario analysis. This scenario presents a common challenge in database upgrades where a critical governance review highlights potential risks related to data integrity and compliance. The professional challenge lies in balancing the urgency of the upgrade with the need to ensure that all regulatory requirements are met without introducing new vulnerabilities or data loss. The strict adherence to the exam's specified regulatory framework, which for C2090-311 is implicitly US-based, given the context of IBM DB2 and common IT regulations, necessitates a thorough understanding of data protection and audit trail requirements. Correct approach analysis. The correct approach involves a proactive and documented risk assessment process that directly addresses the findings of the governance review. This aligns with best professional practices for IT governance and compliance, particularly in regulated environments. By identifying specific risks, evaluating their impact, and developing mitigation strategies, the DBA demonstrates due diligence. This process ensures that the upgrade adheres to established data protection policies and auditability standards, which are critical for regulatory compliance. The emphasis on documenting these steps provides an auditable trail, essential for demonstrating adherence to internal policies and external regulations. Incorrect approaches analysis. An approach that bypasses the detailed risk assessment and proceeds with the upgrade based on assumptions about data integrity fails to acknowledge the explicit findings of the governance review. This constitutes a significant regulatory and ethical failure, as it disregards a formal risk identification process and potentially exposes the organization to data breaches or non-compliance penalties. It also undermines the principle of accountability by not formally addressing identified risks. Another incorrect approach, which involves delaying the upgrade indefinitely without a clear plan to address the governance findings, is also professionally unacceptable. While caution is warranted, indefinite delay without a remediation strategy can lead to operational inefficiencies and security vulnerabilities associated with running outdated software. Ethically, it fails to uphold the responsibility to maintain a secure and compliant IT infrastructure. Finally, an approach that focuses solely on technical aspects of the upgrade, without integrating the governance review's findings into the planning and execution phases, ignores the broader compliance and risk management context. This demonstrates a lack of holistic understanding of the DBA's role in ensuring both system performance and regulatory adherence, leading to potential breaches of data privacy and security regulations. Professional reasoning. Professionals should adopt a structured decision-making process that begins with understanding and acknowledging all formal reviews and findings, such as the governance review. This involves prioritizing identified risks and integrating them into the project lifecycle. A robust risk management framework, including identification, assessment, mitigation, and monitoring, is crucial. Documentation is paramount to demonstrate due diligence and provide an audit trail for compliance purposes. When faced with such situations, professionals should engage with relevant stakeholders, including compliance officers and management, to ensure that decisions are aligned with organizational policies and regulatory obligations.